see, my name is Dimitris. I work in London for a company called Novoda, which is a mobile-first agency. And we're not really the kind of, let's say, outsourcing house. It's more like a consultancy where we join our clients' teams most of the time. We work with them, we integrate and try to get them to work at as efficiently as they can, basically. So that's a very interesting perspective, because you get to see teams from an external point of view. So you can start seeing some common patterns over time, plus, of course, things we've all encountered. And as for the talk itself, testing is not going to be exactly the first or the main point. It's going to be more about making useful testing, not just writing a lot of them for the sake of it. And I'll be focusing around the project I was on last year, but as I said, most of these things are pretty generic. So it was a cross-platform, meaning we were doing both Android and iOS. And my involvement was mainly three parts. So there was BDD, which is the methodology we introduced, gherkin and cucumber, which are vegetables, and Espresso, which is a testing framework, and also small coffee. So this specific one is a project using Android and Java, just to keep it sort of accessible, but you could do it anywhere. If you're using Kotlin, as you may have heard before, you can use your own DSLs and reduce a lot of the dependency on external tools. Depends a bit on what you have, but the ideas should apply. Now, we'll go into more detail about what this is in a bit, but to give you some context about why we introduced behavior-driven development. This was a project where the overall quality was quite low. There were many issues, deliveries were very much hit and miss. And they had a whole summer where they had a lot of deadlines that they kept missing, and basically release day looked like this. So there seemed to be two key problems which are actually kind of related. The first one was how many bugs, the sheer amount of defects that people had to work on. So we, over that summer, looked into Jira, extracted some stats. So the red is the amount of bug fixes they had to work on, and blue is the actual features. Now if you add to this the overhead of having to raise, retest, a lot of cancelled tickets in the mix as well, all that chaos, it might sound a bit like an exaggeration, but if you're a director and at some point you realize that half your budget is going to fixing preventable defects, I think you should start looking for improvements, which is what we did. Now the second issue we had was knowledge sharing in general. I've made the following pie chart for that, where red is the amount of features not covered. So we decided to try and tackle both solutions together. In other words, the problems of quality and the problem of knowledge sharing. And not just knowledge sharing between developers or across platforms, where we would have the Android team doing something and the iOS team doing it completely differently, but also like designers, BAs, product owners, everyone had to get on the same page because they were not. So we started with behavior-driven development. Now the whole point of this is simply to describe what the user does. Not how they do it, what they do. Basically, if you think about it, every functionality, like everything you ever do on your phone, can be described in sort of first principles approach. Sort of as you have a context, like what you're doing, you do an action, something happens. Or sometimes there's exceptions like an external thing happening, but there's clearly the before, the action, the after. Something we saw also in the previous talk, described as given, when, then steps, and we'll be talking about that later. What's difficult when you try to do this is keeping it simple. That's the hardest part, as I came to find out. Anyway, the first thing we introduced was a small meeting called the Three Amigos. So grooming is something fairly common. Development, hopefully we know what that is. The Three Amigos is a very quick, like 1 or 2 minutes usually, a catch-up. When you pick up a story, before moving it from the backlog to in progress, just call over the QA and a BA or PO, however your team is structured, a designer maybe, and just see that this ticket makes sense. Because maybe it did when you groomed it 1 or 2 months ago, but that information might be stale. So it's a quick check that the business knows what they're going to get out of it, the developer knows what they're going to do, the QA knows how they're going to test. So let's imagine a fictional app. So let's say we have a startup and we have this brilliant business idea that based on your likes on social networks, we're going to recommend bars for you to go. This is what we got. So we got this design. For the more observant amongst you, maybe you notice that this is an iPhone X, not an Android design, but that's what we got. It doesn't really matter, because the feature is the same. The user should be able to do the same, even if the small details are a bit different. And we also got this description of what we're supposed to do. So what does the screen we just saw do? It's a welcome screen for new users. Now if you have QA on your team, hopefully they're going to start asking a few questions when they see that, and they're going to get something just a bit more complete. So maybe we find out that maybe they just installed it, or they deleted their local data, or they signed out, or whatever else. So we start gathering slightly more completely, just by having another person involved, we have slightly more complete descriptions of what we're trying to do. So then we try to sort of break it down a bit. So we're going to be looking at these two cases. What happens if you're meant to see that screen? What happens if you're not meant to see that screen? That's it. Now, okay, we wrote down those requirements and we agreed they made sense. Then what? Do we document them somewhere where they just get out of sync and no one cares anyway? Maybe we had some really nice post-its from that meeting, but then the cleaner came. It would be cool if there was a way to sort of always connect what you've written, the documentation that everyone sees, with what's actually happening in the app. And that's where we have Cucumber, which is also a very useful tool. And you probably, the first time you heard about it, you probably heard of it as a testing tool, which is not exactly correct. Cucumber doesn't do any testing. What it does is it's a specification tool. So this here is the description given by Aslak, who's the guy who actually created it. And sort of, long story short, it's meant to concretely describe what your system does. That's it. So let's move on onto the actual writing of these specs. Now, before you saw how you can use a DSL to do that and make it all more readable, there is an optional layer on top, which is the Gherkin language. And this here is what basically, ultimately, this is going to be a test case, but this is a scenario of what a user does. That's the most important thing, focused on the user perspective. Because a lot of these might start with like, as a QA, when I do this. Like, no, the app is not written for what the QA is going to do. It's written for what the user is going to do. So it's important to always remember who you're addressing. So it has a title up there. It has at least these steps. So given is the context, the starting point of our test. When is the action, then is the expected result. Like you saw before, but here it's described in this language that everyone can access. That is its power, I think. This will live in a feature file, which you can see here. So on the top you have a declaration, what this feature does, with an optional description. It can be anything you want. We have our scenarios, so what happens if the user is expected to see the screen, what happens if they're not expected to see that screen, the logic we have. A very powerful capability is the tags. So you're going to see we have one on top which is for the whole feature. That's very useful, for example, when you're grouping your tests up for CI or stuff like that. And also, because we're implementing the same features across platforms, we're also saying what's implemented where. So you can see that this one is only on Android so far, this one's on both. However, it's a bit deceptive. It looks easy enough. It looks like you're just writing the language you've always used. But the problem, what makes it hard, is that this thing is unfamiliar to both the business and to the developers. Developers are used to having sort of autocomplete, very concrete. Like if you do something wrong, you will get a big red error message. BAs, on the other hand, can write completely freely and it doesn't matter. So that's what makes it hard. Getting everyone to write in this semi-structured way, which has to have to make sense to everyone involved. The approach we suggested was this one here. So what we have is a repo just for the requirements, so it has a whole bunch of those feature files you saw. And then this is imported as a sub-repo into Android, iOS, and potentially anything else you want to test. One cool thing about Cucumber is the support it has. So these are the languages it officially supports. There's others like Cucumberish for Swift. There's actually one that, together with a colleague, we're just starting to do that's Kotlin based. But point is, there's quite good support for it as well. Now, you need those two plugins if you're using Android Studio. And you should be good to go, and this now is the proper highlighted scenario you have. So we suggested it, we showed them this, we said what benefits might come out of this. Sounded cool, everyone was on board. So what was suggested from my side at least was, let's do this together incrementally. There's this thing developers do called pairing and checking in every now and then to see how things are going. And they said, nah, it's fine. We'll give us 2 weeks and we'll come back to you with every feature you ever wanted. So have you ever said yes to something but you knew you really shouldn't? This was one such case. And they came back after 2 weeks, and I'm not going to show you more specific, but rather than this, they really took documenting everything a bit too literally. So we had things like every hex color code in there, every string in every language for every client supported was hard-coded in there. Every different variant of the app was, so imagine if you have, we had 8 variants or so for different clients. That was, each one of them had a whole set of the same thing with different colors, texts, functionalities switched on and off, all that. So not only that, but because they were not so used to using an IDE, they were just doing it on text editors. So you'd have multiple feature declarations within the same file, a few random lines of text as a comment here and there, like remember to ask Mary tomorrow if this makes sense. Spoiler alert, it doesn't, but all that stuff. But the thing is, it's not their fault. It's not their fault because it was their first time writing something like this. And to be honest, maybe this is something that we should, or I should be next time a bit more persistent with and take it step by step. This incremental, by the way of doing things is also something new to many people who are outside coding. Most people who work as a BA, for example, sometimes plan something for months, then another year before they actually get to evaluate. They're not used to continuous feedback like we are. So there's a lot of things to think about when you're trying to get the whole team together. But anyway, we thought that we would learn from that, and what we added is a check. So that's Jenkins over there. So now every time before anyone pushes a feature, that goes through Jenkins, and all it does is it tries to parse those files with Cucumber. So at least we know that they are syntactically correct, and our actual CI then won't go crazy because it's trying to parse things that it can't. So a very simple check, but it can save hours. And if we'd done that from the beginning, it would have saved even more. So once that's in place, we feel that we have something we can work with. Next step is adding Git modules, or rather submodules, which is relatively straightforward. You just need to add this in your Git modules file if you're using Git, and then one-time initialization, and you've checked out, I don't know if you've ever done this, but you've checked out that repository as a new folder into Android, into iOS, and whatever else you want. So now you're sharing exactly the same specifications across your platforms. So now this makes a bit more sense, because in the Three Amigos meeting, we can check based on those requirements. Like, okay, these specifically are the scenarios we're going to implement for this story. And everyone knows that, and we can start moving with a better understanding of where we're going. So now let's validate our features using Espresso. The resolution is terrible. So anyway, what happens now if we right-click there is we can actually run our feature screen. There are some limitations, like we can choose to use a flag to say that we want to fail if not all of the features are defined. In fact, the more observant here maybe notice that the last line is highlighted, and those with superhuman vision have seen that this is undefined step reference. In other words, this hasn't been implemented yet. But how does it know that all the others have been implemented? Where does the connection happen between this and our code? So if we have this step here, for example, the way it works is Cucumber is basically just a parser. So it's going to find every one of these strings, so this string here, for example, it's going to go through your code base, and it's going to find the same string with this, in this form, with correct Gherkin annotation at the beginning, which is given when then. The naming is just a convention, you don't have to stick to that, but it probably makes sense. And one thing that's you need to be careful with is that it will work no matter what annotation you put. So you can put given, when, or then, and it will still work, which is weird, but be careful with that. And yeah, so then we have our, I don't remember what that slide is for. I think it's an accident. Altogether, these will live in a step definition. So this is the actual Java code that maps to the feature file we were seeing before. This is very much just a simple collection, so don't worry too much about its architecture. You can keep it in one file, you can split it. You know, I've seen some people think a bit too hard about how they're going to categorize these, and usually, like, they should be a bit isolated from each other, so you don't really most of the time need them to be living, or you don't need to care too much basically about where they are. You have probably more important problems to solve. Now, there's something here, this robot thingy, and let's see what that does. If you've ever done UI testing on the web, you've probably seen the page object model or heard of it. It's basically a nice way of encapsulating all the UI implementation details in a single class, so then you don't have to worry about it. In Android, for reasons I don't know, it's sometimes referred to as the robot pattern, testing robot pattern, but it's basically the same thing. So here we've tried to model this screen here. So this screen here in code would look, or rather in the robot would look like this. We define our UI elements, we have a check that we can make here, and we have actions like clicking. So these here are powered by Espresso, so Espresso is what lets you access and play around with the UI and do all this cool stuff and interactions you want. And then you have a layer of abstraction between the UI details you see here and the actual test in the step definitions, where you just define things a bit more more concretely. There you just say the test robot, the action you want to do, and that's it. So from what you saw at the very beginning, like when we said that, hey, there's this BDD thing, let's try it out, and we showed a sample a bit like the one you saw before of sample feature file, until we got to this, was about 3 months. And there's plenty of work behind the scenes that I cut for brevity's sake, but there was RX, initializing the app, timeouts, all kinds of things that need to be handled before you can make Espresso useful. Because the one, or at least the most significant weakness of Espresso I found, is that it only knows what's happening on the UI thread. So if you're doing reactive, that won't work. It won't know that something's happening in the background. Or if you have any timeouts or weird stuff like that, you need to handle it outside of Espresso. So anyway, we got to the point where this finally worked. We started, or rather we continued measuring our work, and we saw that within those 3 months our bugs were roughly halved. So from 50% we went down to 25%. Bugs that we worked on per sprint. Theoretically, you could say the documentation is at 100%, even if the steps haven't all been implemented yet. You at least have them written somewhere. You have a single source of truth, and that is huge. And the biggest challenge is getting everyone to write good Gherkin. Like, if there's one takeaway from this presentation, it's that it's really hard to get everyone to agree, and even more so to then follow upon the agreement and just think in terms of the user, not what was on your mind when you wrote something, but what the user with the phone in their hands is going to be doing. It's so generic, but it's true. And just one afterthought, one sort of realization I had as I was putting this together is that if you introduce BDD and it's adopted company-wide, which is what we aimed for in this case, and largely it did happen, but the concept of writing clearly your specs and the much faster feedback you have on all levels, not just development, can really be a step towards taking the whole company in the direction of being much more agile and much more adaptive and hopefully collaborating and getting together as a team much better. Thank you.